Well, hello out there. Today we're going to talk about electrical parts, uh, the small parts, not the big solar panels and 52-inch ceiling fans and stuff, but all the stuff it takes to make them work. This company here, Wenzhou, well, whoever they are, Yumao. Let me see what we got from them. We'll go over here to the left. And they've actually got a video here. Let me do that. Okay, you got some big wires goes in a house. If you're going from one circuit breaker panel to another, like you have a couple of 200 amp circuit breaker panels, and you would have that size because you're trying to get more breakers. You can put a 100 amp breaker in a 200 amp circuit box, but you still get to 27 breaker positions. So we have a couple of them, and at the bottom you have to connect them together. That's one of the ways to do it, is connect the bottom. Let's see here. Fellow's going to show you what one looks like. Now, you'll notice on this one, we got two holes on the end. We're going to bolt these down onto the bars on the batteries that connect the cells together. And we don't want them to turn around or something like that and loosen the nut. So with the two bolts, and of course we can use just one bolt in places we need it, but having it on there doesn't hurt you. These long ones, like he's got in his hand here, those are called DT. It's a DT series. This here's a 2-hole DT series. But what you get with the DT is a closed front. Like if you're going to crimp this and then solder it, you don't want your solder running all over everything out here, because if there's any thickness to it, you won't get full contact when you bolt it down. And also, it looks bad and it wastes solder and all that kind of garbage. Now you notice you can get these tinned. This is basically a piece of copper tubing that they've smashed in a die and punched a hole in. These ones you're looking at here, they're made from a solid bar smashed in a die, and then they drill them from the back. So you can get all kinds of nice sizes here that are a really good fit. Now, a standard terminal lug, that you could find these in an auto parts store in the U.S. or electrical supply house. They're made out of copper and then tin plated. The tin plate is corrosion resistance. And you get them to be a pretty tight fit on your wire, and then use a hydraulic crimper to smash them down. You can also solder them on. Being that they're tin, they take solder really well. This is just one product. Let's find some way to close this, or just go on to the next thing. What do we have up here? Okay. Well, as usual, I'm arguing with the tools. Thought I could get all of it in one screen. Anyway, item number 1. Let's just go to the item. I'll just read you the price. This is a list of stuff we got on eBay over the last week. This is a hydraulic crimper. It has like 9 sets of dies for different sizes of those terminal ends. This is for the battery cable size stuff and and much bigger, and some smaller. This one is a 16-ton for $54. Next item. Let's just bring it up to it. We got some of these short tin copper lugs. 50 pieces for number 2 AWG. Boy, I can't remember offhand the amp rating. It's 100 and some, like 165 maybe. We're using 2 strands of AWG in place of 2-watt. It's actually higher amperage, but you can bend it around inside of your circuit breaker boxes. And also, we run 2 strands, one strand to each of the circuit breaker boxes, and then jump to the second one. So basically, both strands are connected to both boxes equally, and they can share the load rather than going to one and trying to jump across. It's just a superior way to hook them up. These are tin copper. They'll get crimped on. A lot of the things like the circuit breakers itself, they're a tubular screw or just screw with a clamp plate. You don't use any lugs on that. Okay, 6 gauge. That's another large size. This one's for a number 10 screw. We have different places where we've got diodes for the solar panels and stuff. We're going to connect a lot of that with 10 millimeter squared wire. That'll either be THHN for inside of panels and general utility inside of the power room, but outside it'll be 10 millimeter squared, and it's a PV wire. It's polypropylene cross-linked electronically or something. Two layers of insulation on it. Tin copper for the conductor. We're using single conductor. You have to downrate the size if you use the 2 conductors that look like Romex. I got the whatever here. There's some more 6 gauge. This has a 5/16 terminal, and these are to connect the solar panel strings to the inverters. 1210, it's the number 10 ring terminal. This connects the diodes, I think. I'm pretty sure this is, no, told you wrong. You're definitely wrong. This goes on the bus bars of the lithium iron phosphate batteries. You have to run the battery negative and then the positive terminal of every battery. That goes back to a thing called a BMS. You'll be seeing that on our purchase list in a week or so. I sent the dog out hunting. He's got the scent. So all I got to do is follow him down to the one we're going to buy. But we're going to use a 12 gauge wire. We could have got these in 1412 or 1210. But I got some other uses I want to use for this. So we just added more to it for the BMSs, and there's 17 of them per battery, and we got 6 of those big batteries. So this is going to pretty much use this bunch. Anyway, these go to something else we're going to show you in a little while. It's a specialty terminal block, because the BMS connects a lead to all these, and then you have a balancer. We're going to use active balancers. That's another 17 wires that's connected. I don't know if this bring up a picture here. If you click on it. Yep. It's just not on the screen. I don't know if I can move that over. I can move this. These are end blocks for terminal block. Well, golly, jumped right out. Scare me. This goes on the end of a DIN rail. These ones in particular are fairly nice. They've got 2 2 screws that make it grab the rail, make it crush this thing onto the rail. And this keeps your blocks from sliding apart and stuff getting down between them. And also when you're tightening the wires, they don't try to twist around on the rail on you and get spaces between them. So that was a nice thing. Next item is semi-related. These are 3/4 inch. You connect 2 pieces of threaded rod with them. I call them coupling nuts. These are zinc plated. They're $1.19 a piece. The 20 pieces of these end barriers was $33.45. These are all delivered prices, by the way. The 1210 with the number 10 screw, 100 pieces was $33.77. So they're 3.37 cents a piece. The 6-gauge 5/16 ring terminal, 100 pieces for $43.83. So that's 4.38 cents a piece. And then the big ones was 100 for $39.29. So that's 39 cents a piece. Some reason those were cheaper. What we do with these threaded nuts is we're going to weld flat bar on edge to them and sink the whole works down into concrete columns. We'll put a piece of threaded rod or a bolt, something come up out of the top of these, it'll go clear of the concrete. And there'll be a piece of plastic, like 3/4 inch pipe. And what that does is it lets you unscrew the bolt out of this threaded thing if you damage the threads on the top or whatever. Well, you want to, it gets real rusty. We use this in industry, like on big machinery. I'd put a piece of 2-inch Schedule 80 pipe down with a big nut on the bottom, about 2 feet down in the concrete, and that way I could wiggle that stud around a little bit in the threads and get it through the holes of the equipment. It's you can measure all you want, but when you go to put it down, something's always wrong, and you might need that 1/4 inch of wiggle room that you can bend an inch piece of rod. Also, I can drive a wood wedge down inside that pipe and hold it to one side. Then let's go on to the next place. What would that be? I'm going to pause for a second while I figure out where I am.